Hello everyone, I am Giulia Salvatori, a third-year PhD student in food science and biotechnology at the University of Bologna. I am really excited to introduce my PhD project on evaluating the impact of processed factors and agri-food byproducts on the physicochemical and oxidative stability of oleogels. So this project addresses a particularly current and pressing industrial challenge: reducing the use of palm oil and other hard fats in food formulations without compromising texture or shelf life of the final food products. But what are oleogels? Let's have a look together.
Oleogels are a class of gels in which a vegetable oil is entrapped in a thermoreversible three-dimensional network using specific structuring agents. In my study, I used rice bran wax, a byproduct of rice oil production, which can form oleogels through a direct dispersion approach. Specifically, the gelator is added to the oil phase, then the mixture is heated above its melting point and stirred continuously to ensure complete dissolution. After that, the mixture is cooled to form a solid network through crystallization. However, in this process, the high level of unsaturated fatty acid in vegetable oil can make oleogels more prone to oxidation, especially if the process is not so well controlled. Moreover, the concentration of gelator can also affect the sensory properties of the final product. Therefore, one of the main objectives of this project was to evaluate how different processing conditions, such as heating time and temperature, affect the oxidative stability and the oil binding capacity of oleogels. Additionally, I investigated the impact of plant fiber addition on the structural properties of oleogels. Among the tested fibers, I also included brewer spent grain, which is the largest solid byproduct from beer production. The results of the study show that low-temperature short-time treatment minimized oleogels oxidation without affecting the oleogelation. Moreover, plant fibers, including brewer spent grain, were able to act as a structural support for nucleation and crystal growth, thus allowing to obtain well-structured and homogeneous oleogels with improved rheological properties and oil binding capacity.
These results paved the way for alternative strategies to develop stronger, clean label and high-performing oleogels. This also confirmed that oleogels formulation can be adapted to the specific food application, making them one of the most promising and suitable substitutes for our fats and palm oil in different types of food products. And that's why we should support and scale up this technology.